So let's solve another question. This is a very simple question. We have to find the mean square value The mean square value means simple area under the squared function divided by the time period. Okay. Now if you look at the time period of the function ft, so since it starts from minus 0.3, this it repeats itself at 3.7, so the period is 4.0. Now if I draw f square t over a period, so it will be minus 0.3 to 0.7, it will be 4 square, that is 16, and from 0.7 to 2.7 it will be 4. Okay, so the area under this curve will be 16 multiplied by 1 plus 4 multiplied by 2, that is 24. So mean square value is equals to 24 divided by 4, that is 6. Okay, now similarly in any question, if it asks RMS value, that is root mean square, so just under root this mean square value, that is under root 6. Okay, so every time whenever you solve the question, remember that you have to be very attentive while reading the question and delivering the answer to the question. Okay, so we will be having many different videos guiding you guys how to attempt the questions in a best possible manner so that minimum errors are there. Okay, now so let me come to question number 9. So this question is again based on the symmetry concept that we have already seen in the question number 1. So the question number 1 was in was of GATE 2018, right? And this question is, I think, of GATE 2016 or 17. I don't remember that. So you can see that the concepts are actually repeating itself. So this question seems to be very lengthy, but if you look at the trick behind the question, that is the symmetry is a trick behind the question, and you can easily solve the question in that case. Okay, so first of all, let me copy the question. Okay, now I can explain you in a better way. Now if you look at here, if you assume that there is no diode, let us first of all assume that there is no diode. There is no need to worry about diode right now. So if you look at here, that if I current enters node A, then there are 3 paths available, that is path 1, path 2, and path 3. Okay, now if you look at all these 3 paths available to the current, these all 3 paths are exactly similar. Okay, so path 1 is from A to B, resistance R1 is there, and at node B, R2 and R2 are connected, right? Similarly, if you look at path 2, so resistance R1 is connected to node F, and F is connected to R2 and R2, right? Similarly, if you look at R1, so A to D, and then D is connected to R2 and R2. So all these 3 paths are exactly similar. Okay, Now since all the three paths are exactly similar, so I can say that all these nodes are at same potential. So I can say that D, B and F are at same potential. Now since they are at same potential and resistance between F and A, B and A, okay, resistance between F and A, B and A, D and A is same R1, R1, R1. Since potential is same, resistance is same, so I can say that this incoming current at node A will split itself into three equal components. That is, here it will be I by 3, here it will be I by 3, and in path 2 also it will be I by 3. Okay? Simple, eh? Okay. Now, at node B, the incoming current is I by 3. Now, if you look at the paths available, so one path is B to C, one path is B to G. Now, if you look at node C and node G, both are exactly similar. So C is connected to R2 and R3, G is also connected to R2 and R3, B is connected via R2 to G and C, right? So this path is also similar. So again, the incoming current I3 will split itself into two parts, that is I by 6 and I by 6. Okay? Okay. So for simplicity, I will draw this again. Okay. So I current is coming. I by 3 will go here. I by 3 will go here. I by 3 will go from A to F. I'm not drawing it, so otherwise it will be very complicated, right? So B to C it will be I by 6. B to G it will be I by 6. Okay. At D also it will be I by 6 and it will be I by 6. Similarly, from A to F I by 3 will come and again it will break to I by 6, and F to E it will be I by 6. Now at node E, I by 6 is coming from D, I by 6 is coming from F, so here it will be I by 3. Similarly, at node G, I by 6 is coming from F, I by 6 is coming from B, so I by 3 will go here. Okay. Now at node C, I by 6 is coming from D, I by 6 is coming from B, so I by 3 will flow from here. Okay. Okay. Now at node H, I by 3 is coming from E, C and G, so I current will go outside. And this loop is complete. Okay. Now, how to find the value of current I? Okay, so first of all, if we look at the input, that is 10 sine t. So input is 10 sine t. So input is something like this, sine wave. So if you look at the input, that is 10 sine t, and the diode direction, then you can see that the current will flow only for the positive input and there will be no current flow at the negative input, right? So the effective input for the circuit is only this much. The effective input for the circuit is only this much. So it is 0, then it is positive, then it is 0, then it is positive, then it is 0. Why it is 0? Because the diode will cut off the negative part of the input. Okay, so the effective input is this. Okay, effective input voltage. right? Effective input voltage is this, right? Now, to find out what we have to find out, we have to find out the RMS value of the current. Now, the RMS value of the current is RMS value of the voltage divided by the effective input, effective resistance, sorry, effective resistance. Now I have to find the effective resistance of the circuit, this whole circuit. So this current division that I have done here will help me in in finding out the effective resistance. Now suppose I just remove this input 10 sin t and this diode also, and connect another wire from A to, I just removed it, okay? I have removed all this. So from A to H, I have connected a voltage, a DC voltage of value V, VDC, and I have removed all this, okay? So this is not in the circuit, just for sake of explanation, okay? And I assume that the current flowing is capital I, okay? And now effective resistance can easily be found out by applying a Kbl loop, okay? So the Kbl loop is A to B, B to G, G to H, and H to A, okay? So this is my Kbl loop. So from A to B, this direction, I can say that the polarity of voltage drop is positive, because plus here and minus here, it is R1 multiplied by I by 3. Then from B to G is R2 multiplied by I by 6. Then from G to H is I by 3 multiplied by R3. Then from H to A, I am entering this DC voltage from negative. So minus VDC is equals to 0. So I can say that R effective, that is equals to VDC upon I, is equal to R1 by 3, R2 by 6 plus R3 by 3. Okay. Okay. So R effective. So in the question, R1, R2, R3 are given to me. Okay, R1, R2, R3 are given to me. R1 is 3 kilo ohms, R2 is 6 kilo ohms, R3 is 9 kilo ohms. So it is 3 by 3, 6 by 6 plus 9 by 3, that is 5 kilo ohms. So R effective is 5 kilo ohms. Now IRMS that we have to find for the solution is VRMS upon R effective. Now VRMS will be calculated from the effective input voltage, and we always know that this is actually a rectified, half wave rectified sinusoidal wave, which has RMS value equal to Vm by 2 divided by R effective. Okay, we know that. And what is the maximum value? Vm, that is 10. So 10 divided by 2 divided by 5 kilo ohms, that is 1 milliampere. So this is your answer. So this again, we have a symmetry concept that I have used again here to find out R effective, and by finding out R effective, we can easily find out the IRMS value, because IRMS value is equal to VRMS effective input divided by the effective resistance. Okay, so after solving this, you can easily see that the value is 1 milliampere. That's the answer. Okay, so let's move on to question number 10. So guys, let's move on to the next question. So in this question, we have to find out the equivalent resistance between point A and point B. Okay. So simple concept is, whenever we have to find an equivalent resistance across two terminals, then only three concepts are used. Okay, so just I am telling you the concepts in brief here. In the detailed version, we will be launching a video series on every subject, and then there you can get all the things in a detailed manner. Okay, so the simple is, the resistance will be in series, and the two resistances are in series. The equivalent is R1 plus R2. So two resistances are in series. The equivalent is R1 plus R2. Parallel. Two resistances are in parallel. The equivalent is R1 into R2 divided by R1 plus R2. Okay, but the third one is very important. That is star delta. Okay. So for example, if you have, so the resistances RA, RB and RC form a delta. Okay, and the resistances R1, R2 and R3 form a star. Okay, so generally the requirement is to convert from delta to star or from star to delta. Okay, so if we want to solve this question, then first of all we have to convert these three resistances. Okay, this resistance and this resistance, which is actually forming a delta, into a star. Then only the question can be solved. So we have to convert delta to star. Okay, so there is a trick to learn the formula. Okay, so we know that R1 is coming from node A. Okay, R1 is touching node A. So the value of R1 will be the resistances of delta which are touching node A. So product of resistances or product of resistances touching node from where R1 originates, divided by sum of all resistances of delta. Okay, got the point? So this is the trick that I have created to learn the formula. So I can say that R1, which is actually originating from node A, it will be RA RB divided by RA plus RB plus RC. Similarly, R2 originating from node B, that is RA RC divided by RA plus RB plus RC. R3 is equal to originating from node C, and node C has RB and RC touching it. So it is RB RC divided by RA plus RB plus RC. Right? Okay. So I will just copy this figure. Okay, so we know what is star to delta, delta to star. and star to delta will be done in the upcoming questions. There are many questions related to this concept in the previous year, so we will be solving that also. Okay, so this is the figure. Okay, so we will convert this delta into star. Okay, so this will be transformed like this. Okay, so when the value of RA, RB and RC, because in this question it is given that all the resistances are of value 1. So when RA, RB and RC are of value 1, then R1, R2 and R3 will be of value 1 by 3, 1 by 3 and 1 by 3. Okay, so if this is node A, this is B, this is C, D, E and F. So this is node A, B, this is F, this is C, E and this is D. Okay, so the delta that was between C, D and E will be converted into a star formation I'm drawing the star formation with pink. Okay, and the value of these will be 1 by 3, 1 by 3, 1 by 3, and rest all resistances are of value 1, 1, 1, 1 and 1. Okay, so it can be redrawn as 1, 1 and 1, okay, so these resistances will be 1 by 3 and 1 are in series, so it is 4 by 3, 4 by 3 and 4 by 3. Now you can see that the combination of 4 by 3, 4 by 3 and 4 by 3 is in star combination. Okay, so you have to convert this star into delta. Okay, so I will copy this figure again. So here we need convert. So we have seen the conversion from RA, RB and RC into R1, R2 and R3, that is from delta to star. So we have seen delta to star. Now we will see star to delta. That is, we have in a question R1, R2 and R3 given to us. We have to find the value of RA, RB and RC. Okay, so the simple concept is value of RA is equal to sum of resistances sum of resistances of star touching RA. So what are the resistances touching RA? That is R1 and R2. Okay, plus product of resistances of star touching RA, that is again R1 and R2, divided by the resistance of star opposite to RA, that is R3. Okay, so if you recall this, if you remember this, then it is RA is equal to the resistances touching it, that is R1 plus R2, and product of the resistances touching it, R1 R2, divided by the resistance opposite to it, that is R3. Now if you look at RB, so RB resistances touching it is R1 and R3, so R1 R3, and the resistance opposite is R2. RC is equal to resistances touching is R2 plus R3, product is R2 R3 divided by opposite resistance is R1. Okay, so this is the formula, you can remember it to convert from star to delta. Now in this question we have a star which has resistances 4 by 3, 4 by 3 and 4 by 3. So if you solve this, you will get 4, you will get 4, you will get 4. Okay, now I have to add a page here. Okay, now this figure can be converted into a delta again. One and 1, and the inner star will be converted into a delta. Four and 4. Now this 4 resistance and 1 resistance are in parallel. This 4 and 1 are in parallel. This 4 and 1 are in parallel. So this can be redrawn as 4 parallel 1 is 4 into 1 divided by 5, that is 4 divided by 5, 4 divided by 5, 4 divided by 5. Okay, so R equivalent is, these two resistances are in series, so this is equivalent to 4 by 5 parallel with 8 by 5. So 4 by 5 parallel 8 by 5, that is 4 by 5 multiplied by 8 by 5 divided by 4 by 5 plus 8 by 5. That is, if you calculate it, then it will be 8 into 4 divided by 12 into 5. That is 8 by 15 ohms. Okay, so this seems to be a lengthy question, but in this question I have told you many concepts that will be helpful to you in solving many questions. Okay, so one more question we will be doing in this video. This question number 11. So we have to find the magnitude of current through R2, through this resistance. It's a very simple question, very basic question. First of all, I'll redraw the figure. Okay. So in this question, first of all, while solving such questions, first of all, just mark all the given information given in the figure. So in the figure, we can see that at this node A, for example, the incoming current is 0.04 Vx. Okay, 0.04 Vx. Another information that is given to us is Vx is the voltage across this 5 ohm resistance. So the current in this branch will be Vx by 5. Okay, always try to solve such questions in the manner that I'm telling you. So Vx is the voltage across 5 ohm resistance. So the current will be from top to bottom Vx by 5. So at node, that is equal to 0.2 Vx. Okay, so I can see that the incoming current in this node is 0.04 Vx. The outgoing current is 0.2 Vx. So easily I can find the current which is coming from the 60 volt battery by applying KCL at node A. Okay, so KCL at node A. So incoming current is 0.04 Vx. Incoming current, let us say I, and the outgoing current is 0.2 Vx. So I is equal to 0.2 minus 0.04 Vx. That is equal to so you can easily subtract it to get the result 0.16 Vx. Okay, so now again I will redraw the figure. Now I have to find the current flowing through the resistance R2. So I have variable Vx in the whole circuit. So to find that, I will apply a KVL. So suppose this is node A, this is B, this is C, this is D. Okay, so I will be applying KVL A, B, C, D, A. Okay, a very simple problem. So we know that the current is flowing in this direction, current is flowing in this direction, current is flowing in this direction, and so voltage drop across R1 will be from A to B will be plus in the left side, minus in the right side, that is 5I. Okay, you can see it here also. Current is flowing from left to right, so plus in the left, minus in the right. 5I plus 3 into the current which is flowing through R2 is also from left to right, so plus in the left, minus in the right, and the current value is 0.2 Vx. Now the voltage across R3 is plus at the top, minus at the bottom, so plus Vx. And moving from D to A back, we are entering this 60 volt at minus terminal. So it will be a minus sign, minus 60 is equals to 0. And we know the value of I also, that is 5 multiplied by 0.16 Vx, 0.6 Vx plus Vx is equals to 60. I have to add a page here. Okay. So 60 is equals to 1.6 Vx plus 5 multiplied by 0.16 is 0.8 Vx. That is equals to 2.4 Vx is equals to 60. Vx equals to 60 divided by 2.4. that is 10 divided by 0.4, that is 25 volts. Vx equals to 25 volts. Now the current through R2 was 0.2 Vx. Current through R2 was 0.2 Vx, that is 5 amperes. Okay, so the answer to this question is 5 amperes. Thank you.